4.3 business formulas. A basic business formula that is commonly used. Interest equals principal times rate times time. I equals P times R times T. I equals PRT. So the example here, if you use the formula I equals PRT and you're provided with P of 7,000, R of 0.09, which is in terms of a percent would be 9%, and T is equal to 2. Time is 2. This could be 2 months, it could be 2 years. In most cases, when we have an annual rate of 0.09, 2 is going to be 2 years. Not often will you come up with a monthly rate of 9%. So this implies 9%, an annual rate, and T would be 2 years. So I equals PRT, we plug in the numbers. P, 7,000, R is 0.09, and T for 2, so 7,000 times 0.09 times 2 gives us $1,260. So I, which is the interest earned on an investment, if you deposited $7,000 earning 9% for 2 years, by the way, this would be what's referred to as a simple interest computation. Then the result would be I equals $1,260. Same thing again, I'm sure you can plug in those numbers. Moving on to example number 3. They're giving us a new formula here. The formula is written as M equals P open parentheses R plus RT, where M is what we would refer to as the maturity value. P is the original interest, and the parentheses starts off with a 1, and that's just a 1, it's just part of the formula. Plus R and T. R is the rate and T is the time. So let's go ahead and plot the formula down so that we could solve. Now in this formula, or this example, they're asking us to solve for R given M is 12,270, so we'll go ahead and 12,270 equals P, well they gave us that, 12,000, open parentheses, plus R, did they give us R? That's what we're trying to solve for. And T is 0.5. So we can use the distributive property in this example. So we're going to get rid of the parentheses, and we know that 12,000 times 1 is 12,000. And we can go ahead and move the plus sign over. And then what we're really looking at now is 12,000 times R times 0.5. Now we're going to focus on the multiplication item first, because we know since this is 12,000 times R times 0.5, then this can be converted to 12. So what we're looking at is 12,000 times 0.5, which would be 6,000. So we've taken the 12,000 times 0.5 and come up with 6,000, which means we can get rid of this. So this can be written again as 6,000 R, which is the same as 6,000 times R. Okay? At this point in time, we could subtract 12,000 from both sides. And what that's going to leave us is 12,270 minus 12,000 leaves us 270. 270 equals 6,000 R. And we're going to divide both sides by 6,000. So these will cancel out. We're left with R on the right side. And on the left side, 6,000. And on the left side, we have 270 divided by 6,000, which gives us 0.045, which is equivalent to 4.5%. Okay, so the textbook goes on to explain how you can take the I equals PRT and convert it to solve for any one of the variables. If you want to solve for P, then you isolate the P, you'll divide both sides by RT, they cancel out, you're left with the P. And to solve for the P then is simply a new formula, P equals I over RT. And the same holds true for other variables in the other formula that we learned. M equals P, open parentheses, 1 plus RT, which the distributive property tells you that P times 1 is P, and then P times RT is PRT. So you could rewrite this formula by simply putting M equals P plus PRT. Now, moving our P over from the right side to the left side means that we'll have all the multiplications on one side and then we'll have a subtraction on one side. So what does that mean? That means we could subtract the right side, we could subtract P, so that eliminates this P, P minus P, that just disappears and you're left with PRT. So PRT remains. So P minus P removes that, but now we're gonna subtract P on this side. So after putting this all together, we can still have a formula called, we can still have the formula M minus P equals PRT. And then if we want to solve, let's say we want to isolate the T, we want to figure out, well, what is the T? We simply divide both sides by PR. That leaves the T remaining. And then M minus P divided by PR, which now, if we have all the information for M, P, and PR, then we can solve for T. Another formula we can see that to solve for T in the formula is D equals B over MT. So we can look, and just with this formula, you could recognize that we could solve for different items just by simply using algebra. So for example, if I wanted to get my ultimate value is to solve for T with this formula, that's the same one as this one. I would then multiply both sides by MT, which means now MT, those two will cancel one another so that you're left with B, and then we'll multiply the D times MT on this side, so we are left with DMT equals B. And then now we want to be able to isolate the T, so we'll divide both sides by DM, which cancels those two out. That leaves us with the T, and then B divided by DM. Okay, another standard formula that you might use in word problems, the formula is G equals NP, where G represents the gross sales, N would be the number of items sold, and P would be the price. G equals NP. They give us find the gross sales from selling 481 fishing lures, from selling 481 fishing lures at $2.65 each. That's pretty straightforward. 481 multiplied by $2.65 gives you a total of $1,274.65. G equals $1,274.65. Example 7, retailer purchased a boat for $2,170. It then adds a markup of $650 before placing it on the lot to sell. Find the selling price. Well, the formula for selling price is going to be this S, which represents the selling price, is equal to C, the cost, plus M, the markup. Pretty straightforward. So the cost was $21.70. S equals $21.70 plus M, the markup, $650. We add those two together. The sales price is $2,820. Often we use formulas to come up with a forecast, and the forecast, generally speaking, will say that there's a relationship between certain numbers. And if one number changes, then that impacts another set of numbers in a way that we can measure it. As an example here, after a significant research, Ben James believes that the dollar amount of Chevrolet vehicles that can be sold in one state can be approximated using the following equation. S representing how much we actually sell. S will equal $40 plus 16.2 times A squared. So this took a little bit of research. We're simply going to be given the formula, and we have to solve for the unknown variable. What do these variables represent, or at least what does the A represent? Because we already know what S means. A is advertising. So what we're really trying to do is see the relationship between the amount spent in advertising and how that's going to impact sales. This formula suggests that there is a relationship. So let's estimate sales for July if advertising is 1.4. Advertising, which is A, is 1.4 million. Here's what we're going to do. We're going to take 1.4 and substitute the A. We're going to substitute the A for 1.4. So S equals 40 plus 16.2 times A squared. That was the original formula. Now within A, we're going to go ahead and plug in the 1.4. So 1.4 squared. Remember that 1.4 is million. And now we'll go ahead and solve. 1.4 squared is 1.4 times 1.4, which comes up to 1.96. And 1.96 multiplied by 16.2, remember the order of operation. We have to do multiplication first. 16.2 times 1.96 gives us 31.752. And then finally, we're going to go ahead and add the 40 to it. So we end up with 71.752. So sales will be 71, and certainly because this was in A was in millions, it's 1.4 million. We have 71,752,000. So that's what sales will be if advertisement is 1.4 million. That completes 4.3.